in listen-only mode.
Good afternoon. This is Julie Blomquist. I'm with the PASS Database Administration Virtual Chapter. Today, we're having our lecture on SQL Server Statistics. The speaker is Srini Julicante, and this meeting is being sponsored by Dell. Dell provides us with the gift card for the raffle at the end of the meeting. We have some upcoming SQL Saturdays. These are one-day free educational events if they're in your area, or you could go to the SQLSaturday.com and see if there's an event near you. The SQL Pass Summit 2014 is coming up. You can register until the 26th, which I think is this Saturday, at a discount rate of $18.95. And if you use the code at the bottom of the screen, VCSUM08, you can save an additional $150. This is the largest gathering of SQL Server and BI professionals. It's amazing, the attendees, the companies, and the number of technical sessions and what's available as a conference for SQL Server. PASS has quite a large number of virtual chapters. Here's a list here, and they're constantly adding them. You would just need to go to your PASS membership, and then you can opt in, tell it what you want to be associated with. You'll then get emails when they're having their lectures and their events. If you're interested in volunteering with PASS, there's a number of methods you can do it. They also have an Outstanding Volunteer Recognition Award and the Passion Award. It's real easy to volunteer, and they're always looking for people and to get involved with the PASS community. And if you know of anyone that you would like to nominate for the Passion Award or as an Outstanding Volunteer Award, there's links that you can go to and put your nominations in. Stay involved with your PASS membership. There's quite a lot of things going on with PASS which are published and with the information. Today, Srini Julicante is going to be talking about SQL Server Statistics. Srini currently works as an enterprise database administrator for the Louisville-based Humana, where he's supporting 16,000 databases on 1,500 SQL servers. He earned his MCITP certificate in SQL Server 2011 and has been working with Microsoft SQL Server for over 10 years with performance and tuning for over 3. He specializes in troubleshooting performance issues and fine-tuning, and he actively participates in presenting sessions on SQL Server Statistics, the SQL Server Plan Cache, and internals for the Louisville SQL Server user group and within his company and at SQL Saturdays. He actively seeks to expand his horizons on these issues and to present to a variety of interest groups. This session is being recorded and will be posted on the DBA Virtual Chapter website. So Srini, I'm going to pass the presentation over to you.
All right. Okay, I can see that. I hope you all can see my screen, right? Julie, can you see my screen?
I can see your screen if you wanted to go into the slideshow presentation to make it bigger.
Yep. All right. Hello, everyone. I think I can start, right, Julie?
Yes.
Hey, this is Srini. I'm going to present today about SQL Server Statistics. Primarily in this presentation, we are going to cover what are SQL Server Statistics, how do they look like, when and how do they get created, when and how do they get updated, when SQL Server kicks off auto updates, and SQL Server Statistics, best practices, and maintenance. We are going to cover all these topics here. So most of the topics are very basic, and I learned these things while working on my day-to-day work. So most of them very familiar what I'm talking here. But if you have any questions, we take those questions on each end of the demo. I have like 3 different demos, so you can pose your questions there. And in this presentation, more often we use some of the new terminology, which are cardinality. This is the main one we talk all the time during our presentation. Cardinality means the number of rows processed at each level of your operators or in your execution plan. We will get some details on those terminology. And the other one is query optimizer. The query optimizer's main responsibility is to generate optimal plans, meaning when I say optimal means optimizer has to work with some cost-based terminology. That means it always generates good enough plans. They may not be best plans for every statement you submit into the SQL Server. We are going to see why and how. Next one is statistics header. This statistics header provides some information about your statistics name, last updated date, and rows and row samples. We are going to see them. And the next term we probably use vector density, or we also call it tensor vector, nothing but how many values you have in your table which are distinct. In simple words, the formula goes 1 by distinct number of values in your table. The next big one is histogram. Histogram is nothing but your data distribution, how you laid out your data in your tables. These are the some of the terms we use. Now let's see what are SQL Server Statistics. Statistics contain a map of the data distribution for a column or an index. It is simply, in other words, distribution of your data in your tables. Query Optimizer uses these statistics to estimate the cardinality. And cardinality refers the total number of rows processed at each level of a query plan. These cardinality estimates enable the query optimizer to create a high-quality query plans. SQL Server estimates cardinalities come primarily from histograms. So that means the histogram is entirely driving for the or providing the estimations to the optimizer. A histogram with the distribution of values in the first column, or we also call it as a leading column of the statistics or the index. A histogram measures the frequency of occurrence for each distinct value in a data set. We also call them as the steps. We will see them how they look. So when I come to the statistics, or when I refer the statistics, actually this object contains 3 different pieces of the information. The top one you are seeing like a stats header, where you can see the information about name. Give me a second, let me zoom in. Let me go back to the slide. When you see here on the screen, this is your statistics name. And when the statistics object really updated, and this explains how many rows in there in the table. This is referring a cardinality of the table. And this tells you how many rows has sampled to compile that particular stats object. And this is nothing but steps. That means in any given statistics object, you can find 200 steps as max. But sometimes you can see 201, that means 201 steps, because if you have a null value on any of your leading statistics, then that gives one more extra step. That means it keeps that kind of information in advance to provide the cost information to the SQL. That means most of the times you can see like a 200 steps, but in some cases you can also see 201 because of null values in your leading columns. And the second one, vector density. This is other information it provides. Vector density, as I mentioned, you can see here showing like a 0.001. You can tell this value comes by doing 1 by distinct values in your table. For example, if I have 100 rows in a table, if the 100 rows are distinct values, no duplications in it, then my value would be 0.01. Simply dividing 1 by 100, I get the all density value is 0.01. That means the all density value lies between 0 and 1. The max you could get 1, the less you go with the 0 point something. That means if you have a 1, means you have all column values are duplicates, no distinct values. And if you are ranging from 0.001, that means you have distinct values in your table. That's how we refer that density values. And last piece part is histogram. This is actually provides the cost information to optimizer. So optimizer primarily depends upon this information. This is nothing but your distribution. How this distribution comes into a play, we will explain. But we need to remember this is just a distribution, how your data is laid out by your statistics object. And the histogram contains some of other information, whereas like a range high keys, range rows, equal rows, distinct range rows, and average range rows. Each piece gives some additional information. If I provide some kind of a way to look at this with an example, if I consider a step 4 and 5, I think you guys can see here, 4 and 5. This is my one step. When I call this one is a one step. So here I am representing like a 160. That means there are 160 values between 107 and 111, excluding these two values. And the 64 represents there are 64 values equal to 111. That means if you have a column value 111, we are going to see that there are 64 values which are equal to 111. And you see like a 3 here. Let me move this one a little bit. So there are 3 means there are 3 distinct values between 107 and 111. And I'm getting this average range rows is nothing but dividing the range rows, what I have here 160, divided by your 3, which you get 53. That means these values we use in our optimizer or in our calculations of the cardinality. We are going to see them. So this is everything we see includes your statistics object. Whenever we refer the stats, you think there are 3 different pieces involved in it. So before I go a little further on this, I want to make sure we are all on the same page and get some kind of a level set here. That means how SQL Server Optimizer works when you submit a statement. And this is the process happens under the covers. Whenever user or client submit a SQL statement as a first step, it goes to a parsing stage. We also call it as syntax check. And most of the time we see whenever you write some piece of code and you try to parse it, there is a button like a right tick mark, and it says syntax error. So that means at first stage, every statement scrutinized for syntactical errors. If it does not find any syntax errors or syntactically correct code, then it passes through and sends to the next stage, which is binding stage. In this stage, it does two things. It checks for objects you have declared in your code, whether exist in the database or not. If those objects exist in the database, and it creates a logical stubs. Even that includes are the true for alias names you declare in your code. If it didn't find any object in the database, it throws the error saying invalid object. You might have seen those errors. So let's say that stage also successfully completed. Then it creates logical stubs or where the optimizer could read the code. That means the human readable code changes into machine readable code, which is we called some machine instructions. That creates their all logical stubs and sends over to the optimizer. This is the optimizer you are seeing on the screen. It takes all that logical stubs and makes the decision. But it does not make simply a decision. Before it makes the decision, it goes through so many other considerations. The first one, it checks for estimated row count. That means what is my cardinality? That means how many rows I'm going to process in this execution or in this batch. Once it gets the cardinality, then it checks for the hardware. So what hardware I have to work with, that's record set. Once it takes the hardware information and it goes back to the configurations. Okay, do I have any configuration settings where I need to obligate to them? So meaning configurations means you can set the max DOP setting 0, 2, 4, whatever you like to set max operation, max DOP setting. That takes under consideration. And you can also do some other configuration settings at the database level. That going to be considered by optimizer. Once that's done, then it goes to query hints. Okay, do I have any query hints in the batch or in a SQL statement submitted? If are there any hints, then it is going to honor them. Query hints means like you can declare like a index seek or index scan, or you sometimes people use like a force order. So that means there are so many things you can use hints and it's going to honor them. Once that's done, and it looks for the access methodologies. Okay, I got the information what I need, but how I access that information? I need to check with the indexes. What I have the indexes, then that takes the index information. And then there are any partitioning I need to consider. If there are, then it checks for the partitioning. And the last one is, am I working with the files and file groups? So it takes all these considerations before it makes a final decision in the form of a execution plan. Once it gets the information, it generates an optimal execution plan, puts them into a plan cache or simply a plan, and the cached plan sends over to a execution engine. So this is actually executable where your parameters and memory allocations get validated and assigned at this point of time. Once that's done and it starts processing and spits out the results to the user. So this is kind of a whole flow happens when you submit a statement into a SQL Server engine. So the big show is here, our optimizer, how the optimizer generates plans, what are the basis for it. Next thing is, we talk a lot about the statistics, then everybody thinking, okay, how do you see them, or how do I see them, how do I perceive them? Then these are the ways you can see the information. DBCC shows statistics, takes two arguments. One is table name and stats name. And I'm also providing the example how you can query that particular stats information. We are going to use that heavily in our presentation. And you can also use SP Auto Stats table name and sys indexes, sysstats, and sysdmdb stats properties. You can combine these three catalog views and get the very useful information. This sysdmdb stats properties object has introduced in SQL Server 2008 R2. If you are using 2005 or 2008 earlier than R2, then you don't find this one. So this is like a patch, and that provides very good information on the statistics objects. So we are going to use that in our presentation too. So now let's see how SQL Server Statistics being created on the SQL. So there are two ways SQL Server Stats created. One by machine or system, other one by manually creating by us. So the query optimizer creates stats for indexes on tables when the index is created. Index stats are created on the key or lead column of the index. The query optimizer creates statistics for single columns in query predicates. Composite indexes creates multi-column statistics. And you can also use, other than optimizer, these commands sp create stats, stored procedure, you create the stats, and you can also use a create statistics statement. And we are going to see a detailed demo about this one. Let me bring up the management studio real quick. All right, I think everyone can see my management studio scripts here. They are very small and simple scripts.
Yes, everything's visible.
And in this demo, what I'm trying to do here, I will create a table with 4 columns. You can see that here. And I insert some data into it, maybe 100,000 rows into it. That's what this code. Let's do that one. Okay, I have created this. What I do here, I just go back to our database, SR demos. You can see that here we are using SR demos. And we'll go back to the table. Our table name is stats impact, that you can see here. And we have 4 columns. And if I go to the statistics, I don't have any stats involved there. If I check on the indexes, I don't have any indexes. Let me bring up the screen a little bit. This is our table. And these are our columns. And we don't have any index, no statistics at this point of time. All right, what I do now, I go ahead and create a clustered, non-clustered index on this, on column X. You guys can see that. So non-clustered index, let's go back and create that one. Okay, I got the non-clustered index there. Let's go back and refresh it. And you can see the index there. And if I refresh stats, and you can see them here. So this is the index we have created, but we never created the statistics. When I created the index optimizer automatically under the covers created the statistics, because optimizer requires some kind of a stats to give some estimations of the cost. So that's what optimizer done that job for us. Let me do this real quick, 1 minute. Bring the font a little bit bigger, 1616.
Srini, we're able to see the screens quite well without the zooming.
Oh, okay, wonderful then. Okay, next, what I do here, you can see the stats information here. You see here the table name, stat, whatever the statistics we have created, the date. And now I go back and try to do some mimic here. What I'm trying to do here, I'm using this column X where the value equal to 100. When I do this, let me go to the execution plan. I selected my execution plan, do it. Now, I know I got 100 rows back. You can see here on the bottom extreme right side. Or if I can go back to the execution plan, if I click on this, my estimated number of rows 100, my actual number of rows 100. That means SQL Server somehow estimated exactly how many rows it can process during that execution of the statement. How that happened? Let's go back and see that. And I know this is my stats name, and I have written already this code, so probably that is the same name. Wonderful, I got that one. Where is my 100? I go back to my 100. 100 is between 97 and 103. If you can see, I just bring up this one. My 100 value is between these steps. When I have value between the step, I depend on my average values. So that means this is called histogram intra-step. That means SQL Server knows if any value lies between 97, 103 or between any step, and it expects the average number of rows column. So that's how SQL Server is really expecting this one. Now what I do, I go ahead and use another where class in a different column name. I don't have any index on the column A. So now what happens, let's see. When I click this one, I get the results back, and then I go to the execution plan. Now I'm seeing like here, estimated number of rows 34, again actual number of rows 34. This is very, very wonderful. That's how SQL Server is working under the covers. But how I got that number, I don't have any stats here, but when I refresh this one, Optimizer automatically created this one for me. If you look at this, this is the one created by Optimizer. When I want to see that information, which column and which stuff is that, I just get that one here and pass values. I'm using DBCC source statistics, which does job for me. Okay, click on. Now, I used in the where class, if you remember or not, this is my column A is equal to 101. I got the histogram on column A. If you want to, you can see that. This is my range high key, column A values. If I double click on that, you can see the statistic column A. You see that? So that means that one created on column A. That's what I got the estimation there. And I used 101. That is a direct hit on the histogram, and it is expecting like 34 rows. You see here, equal number of rows. That's what I was telling. If you are hitting directly on the value, then it takes this value and estimates that many rows. So that's how SQL Server works under the covers for the statistics. So the statistics are the main or the one providing the cost for the SQL Server. Let's see how SQL Server estimates the multi-column values. If I have two columns in a where class, how that gets the estimations. Let's do that. Click on that, my execution plan, go and look for the estimated number of rows. If you look at the estimated number of rows 1 and my actual number of rows 7, that means there is a 6-fold difference. Because this is a very small data set, then you don't think, okay, what is big deal here, like a 1 to 7, only 6 rows. But if you have a larger data sets where you have like a tens of millions of rows in a table, this 6-fold difference could give a big grief and a performance degrade, and you don't know what happened all of a sudden. So what happened here, when I refresh the stats, it does create one more stats. So that means already we have a statistics on column A, and now we are using column B in our where predicate, then it also creates a column B statistics. If you want, you can real quick go there and check for the value. You see here column B. So that means SQL Server created one more for its purposes. So do we get any benefit from that? No, we didn't get any benefit from that. So how we can get the benefit by using multi-column predicates in our statements? What I do before we go that step, I drop the statements what I have created, because they are going to give me a problem if I keep them. And next one, I drop this one. I'm dropping whatever the stats system created here. Okay, I think I have already dropped this one. Let's refresh this guy and delete this one. Okay, when I refresh, I should not see them. Wonderful. Now what I do, I manually create statistics on a multi-column. I can see column B, column A, created. Wonderful. I got the statistics in place. You see, this is the one we have created. So below one, column B, column A, you can see them. And close this one. Now what I do, I just go ahead and run the same statement. I don't change anything and see what happens with our execution plan. We've got the 7 rows back. When I go to the execution plan, now I can see estimated number of rows 6.6667. That means we are almost close to the actual number of rows. That means by creating the multi-statement statistics sometimes will help your predicate. That means if you know you are going to use multi-predicates in your statements, you better to have multi-column statistics. Otherwise, your data could not get the right estimations or right information to the optimizer. So, but optimizer never creates multi-column statistics. But there is another tool, DTA, Database Tuning Wizard, which is introduced in 2005 and 8, but we have back in 2000 also with a different name, that can potentially create multi-column statistics. The good benefit from DTA or Data Tuning Wizard, creating the multi-statements. If anyone have questions, I can take questions, a couple of them. Otherwise, I move on to the PowerPoint slide.
We have a few questions, but why don't we wait till the end, because we're already less than a half hour.
Yep.
Okay.
Sure. All right, we will move on that. So next up, we have seen the creating stats. Now we are going to see the updating stats. When SQL Server really update the stats? SQL Server update the stats when the default threshold meets 20% plus 500. If you have a table larger than 500 rows, then you got to wait to kick off the auto update stats at 20% plus 500. A query compiles for the first time and a statistics used in the plan is out of date. A query has an existing query plan, but a static in the plan is out of date. And you can also do it by yourself using auto update stats or SP update stats stored procedure and update statistics command. When stats not updated, so there are some situations system cannot update statistics automatically. When the cases are index reorg won't update index linked stats, auto create won't work on read-only databases. Even if a statistic becomes outdated as a result of a modification, it won't automatically update after the modification completes. That means you have to have run or use that particular statistics in your execution plans. Otherwise, you can't see them updating it. I will show some of the scenarios how that is going to help. Now, this is kind of a flow chart. I don't think you need to go through this. The chart is telling us in every execution of the statement submitted to SQL Server, Optimizer checks for stale statistics. If it finds any stale statistics, then it updates, except it does not meet the threshold. That means even if the statistics are stale, you didn't meet that 20% threshold, then it does not update the stats. Otherwise, it always checks for that stale statistics. It never misses that one. Now we are going to see when auto update kicks off, what were the reasons, how they look like. And I'm combining here demo 2 and 3 because they two are same in similar cases but different scenarios. Let's go back to the demo real quick. I'm using the Management Studio. I'm on SQL Server 2012 version. Okay, let's see, where is my file? Open project. All right, this one is second one. What I'm trying to do in this, I will create a table and insert some of the rows in it, and I also create non-clustered index on it. I got 121,000 rows into this table, and the table, if I refresh this one, this is my table. I don't have any stats, I don't have any indexes. Now I go ahead and create an index here. I got the index in place. If I refresh this one, I should see the index. And you can also see the statistics on the same name. The index I created on the product ID. Now you can also see, this is important in our demo to make sure we are doing the right thing. And the catalog view, if you see this one, I'm using like a sysdmdb stats properties one, sysstats, to bring that information. In this demo, we need to remember this updated stats date. This is important. We have the date at 12/30/8/39, so this is important. And when I go back, what I do, I have like a cardinality of the table 121,317. If I calculate my threshold 20% plus 500, which is becoming like 24,764. If I need to kick off my auto update stats, which is 20% plus 500, I need to load this many rows. So what I'm doing, I am injecting them 5,000 rows at first stage. And we got the 5,000 rows. You can see that information here. And your date is same, 38/39. And you can see there, same date and the number of rows modified. So SQL telling that many rows we have modified, and our stats statistics did not change. And now I am forcing to insert 19,762 into the same table, and I got that one. When I go back and see the information, my statistics should not change. Okay, mine didn't change. My loaded number of rows are 24,762. At this point, you should see changing this one, but it didn't. I tell you the reason. Now what I do here, I go back here and our target is loading 24,764, but we are short of 2 rows. Instead of inserting 2 rows, what I'm doing, I'm loading way heck of the rows here and do this one, and I got that many. When I go back and see my stats here real quick, if you look at this, my modification still 44,000, my last updated not changed. That means statistics are not yet updated, even though I have modified 44,000. So there is a problem, right? Everyone can think, yep, SQL Server is not doing the right job. There must be some kind of a reason. Then what was the reason is, you have to use that particular index or statistics. So now what I'm doing, I am querying with where class product ID. I know I have an index on product ID, and querying that would change your results. Okay, I got the results back. When I go back and check for the values, my modification value should change. My last updated stats should change. That reflects current time. You see, my modifications become 0. That means I have updated the statistics at 1242 instead of 1238. So that means you have to use your index or statistics in your executions or execution plans. Otherwise, SQL Optimizer does not update your stats because it is very resource intensive, and there is no use updating the statistics if you are not using them. So that is the main idea behind this. So now we go ahead and see the third demo here real quick. I don't know, some reason I am just losing my Solution Explorer. In this demo, what I am doing, I'm doing the same thing, no change at all here, same table, same thing. But one thing I'm trying to show you, different scenario. Okay, we have seen loading the inserts one after other, but what happens if I have a multiple indexes? I'm creating like a multiple indexes on the same table, and I check for the values here. Again, same stuff. If you look at here, I have 3 indexes on the tables, these 3, and this is also 124338, our last updated stats, and I have no modifications. Let's go back and do the stuff. What happens? I'm just trying to show you different scenarios. To load the table or to kick off our auto update stats, we need to load this many rows. But what I'm trying to load, I'm loading 24,775 in one shot. Last time we just have seen a different stages. Now I am loading like in a one shot through bulk load. This is also our scenario in our BI solutions. We always use bulk inserts instead of regular inserts. Then how the system going to impact, we are going to see that. So that means you can see here 24,725. Then I can also query the same thing and show you same numbers here. If I go back there, you can see that modifications 24,775 on each index. That means all the 3 indexes are accessed and updated. Now, still my modifications, my statistics are not updated. Then why? Then I do this. If I do update here, last time I used select, now I am using intentionally update because updates, deletes, everything can used in your execution plans. When I do this, I got the results 3 rows back. Then see how and what happened with our indexes. Now we probably estimate, yes, our update status should get updated. But see what happened here. When look at this one, the first statistics got updated here because we can see the modifications 0. That means, and the time also changed, 45. And the other one is 43. What is this reason? Why other two indexes are not updated, or why other two stats are not updated? Because in our execution plan to update the stats, we did not use that particular indexes. So to do that, I can show you that using, I'm just querying your cache. I know the plan is in the cache. This is my SQL command. If you look at this one, this is parameterized, but that's fine. Still you can see there is an update. This is the statement we have issued. And this is our execution plan. And if you see the stats name, that is the stats we have loaded into our cost estimations, the PK one. Other ones are not used, then they were not updated. So that means, again, optimizer never updates if they are not used in your execution plans. That's how it saves the resources. So this is like an undocumented trace flag. You probably better to not use on the SQL production boxes, at least on R2 and 2008. I have seen some issues issuing this on 2008 and R2. You can pretty much use on 2012, but not on the productions. These things can change anytime. So that's about the second and third demos. And I have one more demo which explains about the parameter sniffing. These 3 slides explains your statistics, and the fourth demo explains what is our parameter sniffing. Every day we face this problem in DBA area, and every day somebody calls you and tells, okay, I have a problem, and suddenly my stored procedure is dying. And they seems to claim, okay, we don't have any changes on the code side or on the application. But sometimes we got to dig and figure out what was the problem, and most of the times we can see that triggering from your parameter sniffing. Again, parameter sniffing is a good one, not bad, but it differs from case to case. Hey, Julie, you want me to go and finish my fourth demo?
Yes. Why don't you continue, and we'll just do the questions at the end.
Sure, we'll do that. All right. So far, how are we doing? Everyone is okay? Kind of boring.
No, you're doing fine. You do have some questions.
So before going to the parameter sniffing problems, I want to give some kind of a background when this parameter sniffing really happens. What was the reason for that? So the main reason is if your data is not evenly distributed and it may not be a consistent across or uniformly, then you tend to see the parameter sniffing problems. That means any one particular execution plan may not satisfy across all other subsequent executions of the statements or the stored procedures. Because SQL Server has to work with only 200 distinct values or distinct steps in your histogram. So it got to comprise and put the information more uniformly. But SQL thinks the steps are uniformly distributed, but that may not be a case when you have an uneven distribution of the data in your tables. So that impacts, that means if you have a skewed data distribution, that can trigger these many problems. spills to disk underestimations, index scan versus index seek decisions, inflated memory grants, serial versus parallel operations, least selective tables joined first, outer/inner choices may differ, and inappropriate join algorithms are selected. So there are so many issues you can see are triggers behind the scenes due to skewed data distributions. These are the two scenarios I captured from some of my research are working on the issues. In red color on the left side, think them are different SQL parameters, or you have one stored procedure and each bar represent different parameter values. So that means when you compile a stored procedure, your query optimizer generates optimal plan for that particular compiled value. And on subsequent executions, you are passing different parameters, and SQL tries to use the same existing plan which is retrieved from your plan cache. Meaning, you don't have consistency across your stored procedure executions. Some stored procedure timings or durations takes 5 seconds, some are 10 seconds, some are minutes, some are hours because of your data distribution. So we will see what we need to do there. And on the right side blue, you can see most of the parameters are same except the two long bars or high bars. I can say that two are like outliers for your data distribution. That means any plan created or compiled for other than the two outliers, you probably okay. If your stored procedure compiled on that big bars, then all other executions for different parameters will suffer. So that means these are different scenarios, how your execution plans works, and why you all of a sudden suffer from the performance degrade on stored procedures because of these situations. And we see the demo for that particular scenarios. Let's go back to our Solution Explorer. Come on, I need to open every time. I don't know why, but we will figure out later. So in our demo, what I am doing, I am using my same database. I am creating a table with two columns, column C1 and column C2. I got that one taken care. And I'm inserting some values here. Intentionally, I'm inserting 1,000 for every record I have on C1, which is again 100,000 rows in the table. I got them there. It might take a little bit of the time. And now what I'm doing, if I go back and select my table, I'm trying to show you what values I have. I have all thousands for C1 and pound for C2. I don't have any other values. That's my distribution. That means all my values are duplicate. My vector density would be 1. And I'm interestingly inserting one value for C1, which is 2000. I'm just differentiating. Otherwise, I'm just injecting this Q in the distribution. If I go back and see the same table, just making sure I'm doing the right thing here, the last value you can see 1000. I think everyone can see it, 1000. Other than this, all my values are same or redundant. Now I go back and create index, because this is first thing we do. And I'm dropping the stored procedure and creating, making sure I have everything in line. It is not fancy, very simple stored procedure. I'm using where class where C1 is equal so and so. Now I go ahead and use execution for this. I open up a execution plan now. Execute stored procedure with 2000. That means my value compiled for 2000. This is my execution plan. You can see the values. my compiled value there. If you look at this one, a parameter list and columns, parameter compiled value, parameter runtime value. So that means my two values are same here. That means I compiled and running with the same value. And I am seeking index seek. I know I'm going to get one row. That's what I expect seek. That's very well fine. When I use the same stored procedure with a different parameter, we know we have all 1,000 values, almost 100,000 values. If I seek on that, I'm going to skew it. That means I'm going to get a longer durations. When I go back, still I'm using the same execution plan's shape. The shape didn't change. But if I look at my actual number of rows, my estimated number of rows are different. I'm estimating one because I know I'm seeking for last time and I'm bringing that many rows. That is like a non-optimal plan. If I go back my compiled value and runtime value, you can see the difference here. If I go back here, let me bring this one here real quick. This is my compiled value, all we know. This is my runtime value. That's the what it's happening. That means it is considering the same execution plan shape, which is not optimal for this case. Now what I do, I simply can reverse it. That means by doing the recompile, it's done. And if I go back and reverse it, that means if I use 1,000 this time, my compile, and I should expect scan now. Okay, this is very good. I would expect scan and my estimated and actuals are same. But if I use the same plan for my other parameter, and it is again going to scan. So you see, I don't need scan because I'm scanning like a 100,000 rows here, right? Do I need to scan entire table for one row? No. So that means that situation is called parameter sniffing. That is because you have a data distribution skew. That means if you have a skew, you see the sniffing. If you don't have a skew in your data distribution, then you don't have a problem with the parameter sniffing. In other words, parameter sniffing is saving your time and execution plans, your memory, CPU compiles, everything. And that is very beneficial if you don't have a skew. If you have a skew, then you are injecting or introducing problems in your stored procedures, which is ultimately we are all calling as a parameter sniffing. We have some solutions for that. Let me see what are those. You can use optimize for unknown. You can use recompile. You can use plan guides. You can use filtered statistics. Or you can also use declare local variables. So using these things, you can most likely control that situation, but depends again how you are going to handle that particular situation is very, very important. I think I'm done with the demos and PowerPoint presentations. We have a couple more minutes. I can take the questions.
Okay, the first thing I wanted to mention is Michael Walter is the winner of our Amazon gift card that's provided by the Dell software company. It is a $100 gift card. PASS will be contacting you and sending that out. So let me go with the questions. What does, does the distinct range rows include or exclude the high key value?
The high key values are not included anywhere. So that means the distinct range all coming from your steps. That means between high key values.
How much time does the SQL engine get to come up with an execution plan before it times out and returns what it has so far for the estimate?
Well, that's actually not exposed to user world how they estimate, but there are like a three flows happens. They call it like a search 0, search 1, search 2. So initially they tries to get the trivial, then goes to different paces, and they have a time bound on each pace and it times out. but I don't have, or they don't expose that particular timeouts on there. But you can see that timeouts, but there is no clock on it, or at least I don't know the exact clock.
Do you know what it means if you display the estimated query plan and it has a timeout error?
On the estimated plans, you should not see the timeout because you are not touching anything. It simply takes the cost values from the statistics and generates. It does not go through the cycle.
Yeah, so evidently I think she's getting a timeout error on the estimated.
Timeout error on the
estimated.
Probably, okay.
I don't know.
So they probably have written too many complex queries, meaning like they are doing too many processings inside.
Does create index with composite keys create multi-column stats?
What was the question? I'm sorry for that.
Does create index on with composite keys create the multi-column stats?
That is correct, yes. When you create a composite index, automatically the same columns included in your composite statistics, yes.
Are there any enhancements in statistics in SQL 2012 or 2014?
There are enhancements in 2014. They enhanced the cardinality estimator. That means how they calculate the changes, but the statistics object does not change, but the estimations, the calculations have changed drastically when you compare to earlier version from SQL Server 7 to SQL Server 2012. So they have almost redesigned it.
Should statistics be auto-created in a data warehouse where the tables contain huge numbers of rows?
I would advise leaving the auto-create on data warehouse or on the OLTP systems, and they may not cause the problems or potential problems on executions, but if you have issues, you probably can turn off the auto update stats. That again depend upon the case by case. So when you turn off auto update stats, you have to manually run the job every night or weekly, depend upon your workloads. But I would suggest better to keep create stats on the system.
And then here's a long one. We have a 1 terabyte data warehouse that struggles with performance during the busy nightly ETL data quality jobs. I have found that 75% of all statistics related to non-indexed columns is auto-updated asynchronously each night, causing a lot of additional pressure on the server. The auto-update stats runs for a total duration of 70 hours each night. I'm not sure if that's right or a typo. Any suggestions for turning of auto-updated asynchronous or auto-update stats altogether, or will create more indexes on these columns help? I'm not really sure what the question is. Do you have an idea?
Yep. Yeah, I got some sense, but let me put this in 2 steps. One is they have a very large database, which is more than 1 tera. And on any larger databases, if you leave auto update stats, that could cause the grief. And usually suggests better to run manually those jobs during nights. Again, if you have too many statistics by column stats or the index statistics, they can take longer and longer durations. My advice being that better to figure out what actually the columns you are using. For example, if you have an index on multi-column, like a column 1, column 2, column 3, and you are using the where classes on a different columns, for the column 1, column 2, column 3, SQL takes only first column or the leading column from your index to cost estimation, and other 2 columns it creates and gets the cost estimation. So my advice, if that is the case, then make sure you will create multi-column statistics as I showed you, and drop all the column-based statistics created by system. That way you can save the time. And moreover, if you use any sampling rate for any of the statistics update, probably you hit with a problem. Then you better to leave the sample rate. And if you tend to see the performance issues, then you go back and fix the percentages. Otherwise, I would leave it to sample rate, and that will finish your 1 tera database probably in a couple hours if you don't mention the sample rate.
And I guess we just have a beginner question is, what is SQL Server Statistics?
Well, SQL Server Stats is nothing but SQL tries to lay down a picture before accessing the data onto the storage engine. Meaning it puts some kind of a cost tag on every column what you are asking. In simple words, it's a data decision how you get the cost estimations. In a simple words, probably, let's say you have, okay, go ahead.
No, you're fine.
I think I come back to that question again if I have time, but if you have any other questions, we can answer them.
No, they're just asking, the presentation is being recorded and it will be posted to the dba.sqlpass.org website. It'll be under the meeting archive tab. And then Srini, some are asking if you would also like to share your PowerPoint presentation or your scripts to have those posted. So that's up to you.
Sure, I can. I don't know, do I need to send to Sharon or you those slides and scripts?
Yeah, if you could send them to both of us, and I'll get that posted as well. But I think that was the last of the questions. Was just the last one was the what is the SQL Server Statistics?
Yeah, okay. If I come back to that SQL, let's think, let me put this in a simple example. If you want to lift a weight, let's say you have a 50 pounds weight out there and no one really marked on that, and you want somebody ask you to lift that one. How you assess that lifting the weight? Do you try to use the finger, leg, or what muscle of your body you use? So that is one example. If somebody sticks on that weight like a 50 lbs, then you predetermine, okay, I need to use my 2 hands to lift that one. So that is the difference of the statistics, how they use. That means it provides some kind of a cost tag on each column retrieval. That's how optimizer can quickly come up with an estimation. Okay, I need to use this one. Okay, view that information. So I can put that way, the statistics is nothing but your cost tag on your columns where you use in a where classes are in the predicates.
It's just this one with SQL. So.
Well, that's it for questions. I wanted to thank you for your time and the presentation, Srini. Is very useful. And we will work to get the presentation and the information uploaded to the website before the end of this week. Thank you again for joining the DBA Virtual Chapter lecture. And I think our next one is slated for October 8th. Thanks again.